This video will demonstrate how to make a cumulative distribution plot and talk about what we use it for and demonstrate how. So here we have some data. These are case weights and grains, and we want to see whether the data is normally distributed, how it's distributed, and be able to draw some conclusions from that data without doing a whole lot of statistics. This is a situation in which a cumulative distribution is very useful. So in order to talk about this, we need to sort our data from smallest to largest. We do that by simply selecting the column by clicking at the top of the column on A. And since we are nice, neat engineers, we will copy that by hitting Control-C, then go over to the next column and paste it. That duplicates our data. This way we have the measurements in the exact same position in which we recorded them. We will do manipulations in column B, and if we screw things up we can always go back to column A and see which data point was which. This can be important if you're measuring more than one phenomenon or more than one characteristic of your data. So we've got our data in column B. What we want to do is sort it. So we come up here to the data button on the ribbon and then sort, and the A to Z button is the sort from smallest to largest button, and we want to continue with the current selection. This is going to ask you whether you would like to expand the selection. Since there are two sets of data there, we want to continue with the current selection. We do this and we see that our data is sorted. We can see this very plainly. So the next step is to number our data in such a way as to count how much of our data is at or below the value displayed in the column next to it. In other words, I'm going to come over here in column C, and first we're going to scroll down with our mouse wheel to see we have 72 minus 1 for this first row. We have 71 data points. Therefore, this first point is equal to 1 over 71 of our data, or 0.014, or 1.4% of our data is at or below this point. If we were to go to the next point, this would be another 1 over 71 plus the value above it. We can continue this ad nauseum, or we can use a very quick tool here in Excel, which is this lower handle right here. And we can select this last cell, and if we were to continue the trend that we typed into this cell, each new cell below it would add 1/71 or 0.014 to the number above it, which is what we want. So we can actually just grab the lower right hand corner of this cell and drag it down. When we do that, we come to the bottom of our data and we see, thankfully, that we get to the bottom of the column and 100% of our data is at or below the largest value, which makes sense. We will call this the actual frequency, which is the common name for this, and it's measured in a percent. In other words, this is talking about the probability that a data point is at or below this value in our data set. Now, if we just wanted to plot these two phenomena, we can simply select the two columns, and in Excel the convention is to have the X column on the left and the Y column on the right. And so we can just select the two columns by coming up here to the top of the column, clicking and dragging, and then go to Insert, and we want to use a scatter plot with lines, and there is our actual frequency. Now this doesn't tell us anything that we already don't know, so we're going to take it out, and like any good engineer we are going to add axes to our data. But first, let's just take a look at this. This is the measurement down here on this axis. We can go to Format Axis and scale it if we needed to. It appears that they've done the scale pretty well. And we can come over here. Let's format this axis so that we go from 0 to 1. So we want the minimum to be 0. We want the maximum to be 1, because we can't have more than 100% of our data. And we can look at this, and very easily we can say, well, based on this graph, 1/2 of our data is below, at or below, about 196 grains. Now this checks out if we come over here and say equals average B to B. This averages all the values in column B. Now you must be careful. If you were to do this in column B below your data, it would include that average in the average. That would be bad. So we usually do this in a separate column. We find that the average is 196.1. 196.1, about 50% of our data is to the left. So already things are looking very much like this might turn out to be a normal distribution. Just for fun, let's go ahead and calculate the standard deviation as well. And this is telling us how spread out our data is around the mean. We see that the standard deviation is 1.74. What this means is if our data follows a normal distribution or something akin to it, within one standard deviation of the mean, in other words 1.73 grains to the right and 1.73 grains to the left, in between those two values will lie almost 70% of our data. According to the normal curve, if we go out plus or minus 2 standard deviations, 95% of our data should lie in there. So what this tells us right off the bat is the limits of where most of our data is sitting. 95% of our data should be within about 3.5 grains plus or minus from 196. So we should have a minimum around 192.5, and we should have a maximum around 199. And we see that our maximum is very close to 199 and our minimum is very close to 192.5. So we can already see that this makes a lot of sense. Next, in the next video, I will show how to construct a normal curve on top of this, and we can compare the normal data to our actual frequency.